today's lecture about explosion. Let's have a look of previous year's students' work and, as an example, what you should create. In this laboratory work, we are going to work with fluids and particles, and we are going to create some environment for the explosion and render them out. Let's see how students deal with this question. Some of students used, we don't have a really good internet connection, sorry, maybe I should switch to another Wi-Fi. And let's see examples. Yes, this is better Wi-Fi. Some of students add also audio on the post-production, and you can use audio or don't use it, depends on you. But the basic idea is to create really good-looking explosion with some environment, and the time of this video can be 3 seconds or 4 seconds long. That's why it's not you don't need to create a really long video. And let's see another examples. Why it's not open? Maybe we can download it. Some students also create some idea of this explosion, explode some building or volcano. Maybe we can refresh. Sorry, the music is really loud. But it was the concept of the student. You can use another music if you want. This is several examples of explosion. Some students create some camera movement to achieve more dynamic in the video. And this one is also good. Some of the students submit without render. Without render, you will also get less points. Neither you are going to render out. It's better to use some environment, explosion, and render this out to achieve maximum points. Okay, this is example of student works. Some of explosions looks really peaceful and detailed. Some of students used Blender, some of them used Maya. And also you can watch some another tutorials to achieve more realism in rendering of this explosion. There are different ways how you can create this explosion. You can use only fluids. Some of the tutorials shows this way. And if you want to achieve some more massive explosion, we should use particles and emit fluids from particles. And today I'm going to show you how to use the second variant with the particles. And also some of the tutorials used to befrost aero. If you use this plugin, your explosion will be more realistic, neither just fluid, but also you can find some tutorials of using bifrost aero, um, or you can use some simple tutorials to achieve this explosion effect. Original tutorial, I can share with you a link with this original tutorial. You can also watch this, but this tutorial is in Korean language. You can switch on English subtitles and watch some settings of this explosion. This is also useful because in this tutorial, really good settings for the quality of this tutorial. And the second part of this tutorial is about rendering. You can also watch the second part and use in your work. The deadline of these explosions is already in the Teams. You can submit earlier or until the deadline. The deadline will be next week on 23 of March, and we postponed this deadline because of the celebrating of the previous week, and the previous year's week was in Russian. That's why we decided to repeat this lecture in English. But I hope today's explosion will be also natural, like in the previous year. I forgot some settings. Maybe today it will be more less quality, neither in the previous year. If you want, you can use some AI AI tools to create transcript from YouTube videos. This is a Monica. You can use this Monica to transcript every video you want. Sorry. Where is Monica? Sorry. Maybe this one. Yes, this one you can use, and you can also put every lecture in this link, and you will get some transcript from this video. Where is? Okay, maybe you can try it by yourself, and because I've already used this plugin, maybe that's why it's not working. If you put some YouTube tutorials here, you will get some transcription or and summary from the video. It's really useful. You can try it. It can be in English also. Maybe it can be useful in some cases. Okay, let's go back to the Maya and let's start to create effect of explosion. we start with the new scene, and I'm going to add some particle system here. Let's create a simple particles emitter. We should change emitter type of these particles to directional. I'm going to change its direction to the 1 on Y and 0 on X. Maybe -1 on Y. Or maybe just 1. And also in the nucleus, in the emitter, we should switch off gravity. Ignore solar gravity, and the direction of these particles becomes up. We should create the origin of this explosion. We need to make some particles moves like fontaine and really fast fontaine. That's why we should also go to the particles emitter and make some spread of these particles. If we add some spread, we will get some fontaine effect, something like this. We should change the particles rate number to the less and make 100. And if we have 100, we have this origin for this explosion. It's look almost like explosion. It's like boom, and from these entire particles we are going to emit fluids, and we will get this massive explosion effect. And also in these particles we need to add some speed, maybe to the 10. Next we are going to decrease maybe not 10, maybe 5 for now. We should decrease lifespan of these particles. We need constant range, about 2 seconds. It's just about boom and done. And also we should animate this emitter for the 10 seconds long. Let's also increase the timeline. We need about 130 particles, and that's enough for the simulation, because we are going to render only 3 or 4 seconds, and you can calculate the timeline for this effect and put animation in the timeline according to your desired length. And also let's come back to the particles rate. We are going to put on the 10 frame, we are going to rate 100 particles. On the 11, we can switch off this particles rate, and we will get this boom effect from the particles, something like this. It's just spread away and disappear. Next, we need to add some little bit gravity to these particles, but we can't use our gravity field, solar gravity, because these particles start falling down and we will not get this massive explosion. That's why we can use some fields like uniform. We can use this uniform field on the particle selection, and we are going to use directional 0 and -1. It will be something like gravity. Now you can see how these particles start falling down until it's not disappearing with this lifespan. I think it's almost enough for now. Next, we are going to add some speed random to achieve some randomization of these particles. Some of these particles go up with some chaotic way. Next, we are going to add some maximum distance. We can put maximum distance to achieve much massive explosion on above. The next, I'm going to find some what we should do. We already use some uniform, we already use some particles, and next I think we can change some particle size, maybe later. Okay, let's emit, let's save this file. And we're ready to add some fluids. Let's add some 3D container, delete this fluid emitter inside of this container. We are going to select fluid and particles and add some container. Emit from object, and now our particles becomes emitters for these fluids, and we get this effect. Next, we should change position of this container. We can change the size of this container and use it more. We should switch off the boundaries. On the boundary Y, we should press minus Y side, and also we can increase the base resolution. First we start with 50, next we are going to increase it until 150. And now we get this effect. We should put this 3D container a little bit above, around our grid. It's almost where we get our particles. And now we have this origin for the fluids. Next, I'm going to switch on dynamic grid for the temperature and dynamic grid for the fluid. It means we are going to use some color from the temperature in the fluid shape. If you remember previous work, we start to use incandescence as a color. And if we switch on dynamic grid for the temperature, we can use these settings to inherit color from the incandescence. It's not seen now, maybe we can see it later. We can also, in the shading, we can switch on self shadow. In the fluids, we should also add some more. In the fluid emitter, we can increase the particles rate, fluids rate, to get it more massive. Also, in the emitter, we can increase the voxels to the 2, and what else we should switch on? In the shape, we also, in the content details, we are going to use swirl. In the turbulence, maybe another interesting some settings because there is really a lot of sensitive moments. Maybe I can watch it. In the particles, I forgot about conserve. Uh, in the dynamic properties, we should make it less. Let's see how it looks. Maybe we can don't use some conserve. I think it's better to do not use this one. Next, I'm going to add we can select particles and fluids and add another interesting point like a per point emission rate. It helps us to create some differentiation between these particles, and this fluid trail can be different. Some from one particles it can be more wider, from another it can be more deeper. And if we add this per particle attribute inside of this fluid, we can inside of the particles emitter we will get some settings. If we do select our fluids and particles and add this use per point emission rate, we will get this um, parameter switch on, and we can change the rate of these particles, and we can make some randomization from this rate. And we can also use per particle radius. We should go to the particles, and we have some per particles attributes, and in here we already have some expression. We add this parameter and we can change this expression. Let's open this expression with the right mouse button and create some expression. We can select these two objects. It's already selected, and select this object attribute. And we can write down some expression that will help us to randomize these trails from the particles, and put the one in the expression and create. Okay, first expression it's done, and let's see what we have. We have different trails from these particles, and also we can randomize the particles radius. We should add dynamic attributes, general, and find some per particles radius. this radius pp. Okay, we've done it. And here we can also create some expression. We should select this one. It's already created. Okay, let's see. We can see previous one. Maybe we can add another one about the particles radius. And in this expression, not about rate, it's about... we don't need the expression about the particles radius. Let's keep it. We can change inside of the particles, we can change the shape and make some... we should change the particle size and radius scale. We can change it with this ramp, and original radius can be 1. And let's see, now we have different size of these trails, some of them huge, some of them less. It helps us to create some randomization of this explosion, and now we can see how it disappears. I think we have done with the origin of this explosion, and we can move next. For the better parameters, you can also watch previous year's lecture, and even if it's in Russian, you can see which parameters and I was chosen because previous years it's much better. Okay, maybe in fluid shape, we already have to change some transparency, make it less. Inside of the incandescence, we can switch on density. And about the color, we are going to use some black colors, gray and black colors, with some bluish and black and gray colors about the color. And now we can see how changed our explosion. And in the particles, we also can change the speed, make it inside of the emitter. We can make some much more inside of this speed. Maybe about 10. Inside of the fluid emitter, we can increase the numbers of particles rate more. We should also change fluid drop off, and let's see what we will get. It's more massive now. Uh, we should also switch on use per particle radius. If we use per particles radius, now we inherit uh, the radius from particle to the fluid, and we get much more massive fluids now. Next, we can go to the fluid and change it shading as well. We can change the opacity. We can add some textures on it. We will use some texture incandescence and texture opacity. We will not see these textures in the viewport, and that's why already we can use some Arnold render preview to see what we've done. We can use some simple directional light to see what we've done for now. And let's render. For the particles, don't forget switch off display visibility and lot visibility. And now we can see only with fluids now. Next, I'm going to change some intensity of this light, maybe more. Let's use 10. And what is also sensitive. Uh, Inside of the fluid settings, we have some temperature settings. We can use some turbulence inside of the temperature. Uh, let's see about the parameters. But before the temperature, let's open let's add some new turbulence speed for this fluid. We can select fluid and add some turbulence inside of this fluid. And this is another field. And we can change some expression for the phase Y. We can create new expression and add some randomization with the timeline on this phase Y. It means if you add some randomization on this phase, it will help you to achieve some changing this parameter according to the timeline. For example, on the 0 timeline, on this 8, and we will get every time randomize with this expression this parameter. With a simple adding expression about phase Y equal time. And now it also help you to randomize and get some turbulency and faster this field. And also we can increase the magnitude of this turbulence. And our fluid becomes more interesting and chaotic. And let's see what we have. Okay, we're ready to move next. Let's go to the fluid emitter and change, bless you, drop off even more on the 0.2 and see what we have. This really depends on the parameters. Maybe we can see what we have now for now. And let's go to the fluid and let's work on this color, on the shading. Let's change the position and we can start change the color. If we put input biasy, we get already some colors inside this fluid, maybe more. And it already looks almost like explosion, and we can continue change these parameters. According to this gradient, you can manipulate with the color of this fluid, with the density, with the colors. You can switch it to the more orange, more light. It depends on your feelings also. You can use more yellow here. What else? Inside of the textures, we can also randomize texture origin on the Y, and we can create expression also about the time. There is really simple expressions, but with these expressions you will get some chaotic meaning on the turbulence and on its textures. And if we use these parameters, we will get some more texturized explosion. Depends on time. Okay, let's save this result. Next, I'm going to increase the base resolution. If we increase the base resolution, our fluid becomes really slow to calculate, but we will get more shaded and quality explosion. In this work, we are going to use some cache also and calculate this cache. But before the cache, let's see how it works. There is some parameters inside of the fluid shape and the temperature. Let's see what we should change in these parameters. It is better to you to watch previous year's lecture because there are more focus about these parameters. Maybe we can increase some turbulence and we can increase some dissipation in the temperature as well. And let's see how it affects on our fluid. And see on the render as well. Maybe we'll also add some noise. And let's see. Let's already make some cache. We will increase some base resolution and we are going to calculate some cache. Let's save before the cache and create new for the Maya fluid. And I'm going to save this into my folder. I'm going to create new one. And let's use this folder and let's create. If we change some colors, changing the colors it not affect on the cache. We are going to calculate the behavior of this explosion, and after that we can easily change some settings for the color and texture of this fluid. If you want to change the behavior of this explosion, you can change the particles. If you change the speed, for example, you can increase the speed and you will get massive explosion and really fast. If you want to change, make it small, you can also adjust settings to the particles. Fluids it just repeat uh, the behavior from the particles. And on the fluid, we can change how much we have on the fluid shape according to the base resolution, and we can change the color and its opacity and texture from this fluid. I will put some pause while it's calculating.